Everyone, myself, Josh. I'm from Andong National University, and my professor is Wei-Yun Huang. The topic of my presentation is mechanical separation of SPR joints for recycling. Composite materials are preferred for many engineering applications because of its durability and superior strength. Proper waste disposal and recycling at the end of the useful life of composite materials is necessary. Many current and future waste management and environmental legislation will mandate engineering materials to be properly recovered and recycled. From products such as automobiles, wine tubes, and aircraft that have lived their useful life. The disadvantages of composite materials are durability, superior strength, and low density. For accomplishment of requirements on the design flexibility as well as performance, many researchers have interest on the metal composite hybrid structures. So multi-metal structures design is needed. First, why recycling is needed? One of the reasons is need to save resource and protect the environment. Second one is industry adopt development needed. Is the last one is legal requirements and policy support. The difficult in recycling composite materials is complex due to the complex structures, and carbon fiber composite materials is a combination materials which are the materials making recycling more difficult. The most difficult in separation process due to large contents of adhesive joints and mechanical joints. Many types of mechanical joints used in automobile such as SPR joint, weld joint, and other mechanical joints. We use discernible materials. Mechanical fasteners or adhesives are initial to join between two materials. One of the possible mechanical joints between metals and composites is self-reinforced rivets. SPRs is a cold-forming joining technique used to fasten sheet metal material by mechanical interlock. Automotive industries are increasingly adopting this technique because of the growing use of lightweight or dissimilar metal supports such as aluminum and magnesium alloys that is difficult to weld. During SPR joining, a mechanical interlock is created between the sheets by forming of the rivet in bottom sheet on the guidance of rivet interlock geometry and a die. Therefore, separating or removing joints is the first process to recycling metal composite structures, and drilling, grading, punching can be used to remove SPRs. So here our objective is remove SPR joints for recycling multi-material structures with an increase of recycling rate as well as reducing the joint strength for easily separation. Our strategy is do the drilling test and pure test. Finally, we will analyze the materials and methods. Aluminum 7075 with which thickness is 2.5 and CFRP which thickness is 3.75 mm composite materials are used. Is CFRP and aluminum peroxides, and the rivet materials is high strength. We make aluminum and CFRP coupons first, then we joint coupons by SPR, then we fix the coupon for drilling test. Finally, we did the PR test. For drilling test, we used 3 different diameter drill bits with 4 3.5 3mm, and we control the feed rate in constant, fix the drill position in the middle of the rivet. Also, we control the drill direction from metal part to composite part. We record the date by placing a load cell at the bottom of the test sample. We create a small gap in front of the specimens to fix the support jig for separation and attach support jig with specimens to perform pure test. And we used universal test machine SDWS 2013 R3 to complete this test. The following 3 pictures show how we make the gap. For pure test, we attach support jig at the end of the specimen, fix the composite part, and give force in the metal part until it separates. Result and discussion. I will show the required force to drill out the rivets which different drill bits in 3.5 and 4 mm. We can see that different force is needed to drill out the rivets with different drill sites. We can see the load strength during the drilling test. In 3 mm case, the drill bit drilled the aluminum head first, then drill out the SPR joints. So there are 2 peaks shown here. In 3.5 and 4 mm case, it drill out SPR immediately. The strength of rivet was measured by experimenting test by pure test, and we set the test machine as follows. As a separating force with different drill diameter. When the bit is not used, the force required for separation is the maximum. The larger the diameter of the bit, the smaller the force required for separation. The loss of materials is proportional to the diameter of the bit. The larger the bit size, the more material loss. It can be said that small diameter bit specimens need large force to separate but drilling force and the material loss is very low. There is a section view before separation test. In 3 mm and without drill case. In 3.5 3mm case, there are some showing cracks here, and in 4mm case, the specimens were separated just by drilling. And in 4mm case, metal substrate was filled and SPR was pulled out from composite. In 3 and 3.5 and in 3.5 and without dual case, the SPR was pulled out from metal substrates. Conclusion and future works. Large conclusions. The large diameter of used drill, the metal loss increase, the joint strength of SPR decrease. Second one is metal loss can be decreased by grading drilled material. Third one, yeah, separation is more important for the recycling process. Last one is we have to find the optimal drilling conditions for grading separation by drilling. The future works, we will drill test with drills of which diameter are larger than 4mm, and we will separate simulations for analysis of the effects of drilling. Thanks for attention.